All right, in this video, we're going to do a brief introduction to factoring a sum or a difference of two perfect cubes. Before we take a look at what a sum or a difference of two cubes is, it's going to be helpful for us to know how to identify perfect cubes. So what do I mean when I say a perfect cube? A perfect cube is a number that results from multiplying a number times itself 3 times. So in other words, 2 times 2 times 2 equals 8. 8 is a perfect cube. And the cube root of 8 is 2, because you have to multiply 2 times itself 3 times to get the perfect cube of 8. 3 times 3 times 3 is equal to 27. 27 is a perfect cube. And 3 is the cube root of 27 because we have to multiply 3 times itself 3 times to get the perfect cube of 27. So here we have a list of perfect cubes. 1 is a perfect cube because it's 1 times 1 times 1. 8, of course, is a perfect cube because it is 2 times 2 times 2, or 2 cubed. 27, 64, 125, and so on. So it's going to be helpful for us to be able to recognize perfect cubes when we see them. Now, what about variable expressions like x to the 6th or y to the 3rd? How can we identify if variable expressions are perfect cubes? Well, let's take a look and see if we can identify a pattern. Let's start with y times y times y, or this could very well be x times x times x as well. Y times y times y is y to the 3rd. Well, y to the 3rd is a perfect cube because it is y multiplied by itself 3 times. So y to the 3rd is a perfect cube, and y is the cube root of y cubed. Another example would be y to the 2nd times y to the 2nd times y to the 2nd. Well, that would get us y to the 6th power. So that means y to the 6th power is a perfect cube, and y squared is its cube root. One more example. Let's do y to the 3rd times y to the 3rd times y to the 3rd. Well, that would be y to the 9th. Y to the 9th is a perfect cube, and y to the 3rd is its cube root. So do you see a pattern developing here? Anytime we have a variable expression and the exponent of that variable is a multiple of 3, or another way to say that is, if the exponent of the variable is divisible by 3, then that variable expression is a perfect cube. How do we find the cube root of a variable expression? To find the cube root, all we have to do is divide the exponent by 3. The cube root of y to the 3rd would be y to the 3 divided by 3, which is y to the 1st. The cube root of y to the 6th would be y to the 6th divided by 3, which is y to the 2nd, and so on. Now that we know how to recognize perfect cubes, let's figure out where a perfect cube comes from, or the sum or the difference of two perfect cubes. Where does that come from? So let's multiply this binomial x plus y times this trinomial x squared minus xy plus y squared. Let's FOIL it out. X times x squared is x cubed. X times negative xy is negative x squared y. And x times y squared is xy squared. Now y times x squared is x squared y. Y times negative xy is negative xy squared. And y times y squared is y cubed. Now let's combine like terms. Negative x squared y and positive x squared y add out. Xy squared minus xy squared adds out. And we're left with x to the 3rd plus y to the 3rd. This expression, x to the 3rd plus y to the 3rd, is a sum of two perfect cubes. It's a sum, of course, because we're adding two terms. And it's a sum of two perfect cubes because x to the 3rd is a perfect cube and y to the 3rd is a perfect cube. So anytime we have a sum of perfect cubes, the factorization should look like this FOIL. But if I'm trying to factor this sum of perfect cubes, that factorization or that FOIL looks like a hot mess. Like, how in the world could I ever remember that x and y and x squared and xy and y squared? How in the world could I ever remember or come up with a way to remember how to factor a sum of perfect cubes? Well, there is a pattern to this FOIL or to this factorization. We just have to be sharp to realize it. So in the next video, that's what we're going to do. We're going to look at a sum and a difference of perfect cubes and see if we can identify a pattern in the factorization to help us remember how to factor a sum or a difference of perfect cubes.